Let us start carbonyl compounds. In the carbonyl compounds, we will discuss tolerance test. Tolerance test. The tolerance test is for identifying aldehydes. How it is that we will see. Now we'll take aldehyde. We'll take aldehyde. We are taking. We are adding tolerance reagent. Tolerance reagent formula is AgNH3 twice plus aqueous complex ion. Medium is what means basic medium. Medium is basic medium. These things we have to take and warm the contents. So how to do this? That means we have to take a test tube. In the test tube, we have to take this aldehyde. We have to take this tolerance reagent. We have to take. Then this test tube we have to keep in water bath. Water bath, how it will be there means that vessel will be like this. That water bath vessel will be like this. In this, we have to take water. Water we have to take. This water bath we have to keep over the flame. We have to keep over the flame. Then this test tube we have to keep here. This test tube we have to keep in the water bath. Then in the water bath we have to heat the contents. So what will happen? What will happen that we will see. What will happen means this RCHO, this aldehyde is converting into what? That point we will see. This aldehyde is converting into so and so RCOO minus carboxylate anion. This aldehyde is converting into carboxylate anion. Next, what is happening means in this AgNH3 twice plus, how it is there? AgNH3 twice plus, how it is there? That we'll see. It is NH3. Another NH3 is like this. Another NH3 like this. Here positive charge is there. This Ag plus takes electron. This is taking electron and becoming Ag. It is deposited. This Ag is deposited in the inner wall of the test tube. In the inner wall of the test tube, this Ag is deposited. Therefore, this inner wall will appear what means silver. Silver will be there. In the inner wall, what will be there means silver will be there. If you look at this silver, it will act like a mirror. Therefore, we will say that we have got silver mirror. We will say we have got silver mirror. We will say okay. That silver. Therefore, this test is called silver mirror test. This test we are saying that silver mirror test we are saying okay. So that in this test, what happens means this Ag plus takes electron and becomes Ag. So we are getting silver mirror. That means this Ag plus undergoing reduction. Ag plus undergoing reduction. This ammonia molecules leaving as it is. This ammonia molecules leaving as it is. This is aldehyde. This aldehyde is converting into what in the sense carboxylate anion. Carboxylate anion. Okay. This is called reducing hydrogen. This is called reducing hydrogen. Reducing hydrogen means due to this another substance will undergo reduction. It itself undergo oxidation. Okay. So due to this Ag plus undergoes reduction and becomes Ag. It undergoes oxidation. Therefore, it becomes H plus. That H plus takes this OH minus and becomes water. Okay. Therefore, this aldehyde is having reducing hydrogen. Therefore, it reduces tolerance reagent. Set. What about ketone? Now we will take ketone. Ketone is not having reducing hydrogen. Ketone is not having reducing hydrogen. Therefore, it is not reducing tolerance reagent. Tolerance reagent is a mild oxidant. Mild oxidant. Therefore, ketones cannot reduce tolerance reagent. Similarly, tolerance reagent cannot oxidize ketone. Okay, we cannot say that ketone cannot undergo oxidation. Ketone cannot undergo oxidation easily, but under drastic condition, ketone also undergoes oxidation. Okay, so this ketone is unable to reduce this mild reducing agent tolerance reagent. So tolerance reagent oxidizes aldehyde but not ketone. So using tolerance reagent, we can distinguish whether the given carbonyl compound is aldehyde or ketone. We can distinguish. Okay, so next test is called Felling's test. We will take. Next we will take Felling's test. What is the Felling's solution? That we will see. Now we are going for a Felling's test. In the Felling's test, what is the Felling's solution? We will see. Felling's solution in the sense It is alkaline. Alkaline in the sense base will be there in the Fehling solution. Then copper sulfate solution will be there. Copper sulfate solution will be there. Then complex will be there. What is a complex in the sense sodium, potassium, sodium, potassium tartrate. Sodium potassium tartrate is the complex present in this. The sodium potassium tartrate is also called what in the sense Rochelli salt. Rochelli salt we can say. Sodium potassium tartrate Rochelli salt is there. This cumulative is called what in the sense Felling's reagent. Felling's reagent we can say. So Felling's solution means here base alkaline solution. Base will be there OH minus. Copper sulfate will be there. Copper sulfate blue color. Sodium potassium tartrate is colorless. Sodium potassium tartrate is a complex salt. Sodium potassium tartrate is not complex. Sodium potassium tartrate is from tartaric acid. Tartaric acid formula is what in the sense this is the tartaric acid formula. Tartaric acid formula is this one. Now sodium potassium tartrate in the sense what is the meaning means instead of these hydrogen atoms what is replaced in the sense Na plus and K plus is replaced. It is called sodium potassium tartrate. Okay, this is this sodium potassium tartrate, the copper sulfate aqueous solution, this alkaline combining together is called Fehling solution. This Fehling solution will appear what color in the sense blue color. Now we have to take aldehyde in the test tube. We have to add this Fehling solution. We are adding this Fehling solution. Now it is in basic medium. This solution, these contents we have to keep in a water bath and we have to heat. We should not heat these contents directly. Through water bath only we have to heat. What is the difference between direct heating and water bath heating? That we'll see. Direct heating in the sense the test tube will be shown like this. Here heat will be much. Here heat will be low. Here heat will be low. That means from flame heat is distributed into the test tube solution non-uniformly. But in water bath, we are taking like this water bath. In water bath, we are taking the test tube. In water bath, what is there means water is there. Water bath is placed over the flame. In water bath, what happens means heat is distributed into the test tube solution uniformly. Okay, sir. Direct heating will not be there uniformly and much heating will not be given at a time. Okay, sir. So here what happens means this aldehyde is having reducing hydrogen. This is reducing hydrogen. This is converting into what in the sense carboxylate anion. Aldehyde is converting into carboxylate anion. This is Cu2 plus. Cu2 plus taking an electron and becomes Cu plus. Cu plus is called cuprous. Cuprous is converting into cuprous oxide. Cuprous oxide is a precipitate that is what color means red color. So if this aldehyde is a liquid, copper sulfate solution is a liquid, alkaline is a liquid, sodium potassium tartrate is liquid. So everything is liquid in the solution in the test tube. Now once cuprous oxide is formed, red precipitate will be settled down. Red precipitate we can see in the test tube. Okay, so aldehyde is giving this test. Aldehyde is giving this test, Felling's test. So test in the sense aldehyde is converting into carboxylate anion. This Felling's cuprous, this Felling's cupric is converting into cuprous. Cuprous is in the form of cuprous oxide red precipitate. Cuprous oxide red precipitate. Ketones do not give this test. Ketones do not give this Felling's test. So aldehyde is giving Felling's test. Ketone is not giving Felling's test. Like that we can say. Next, Benedict's test. Next we will see what in the sense Benedict's test we will see. Next we are seeing Benedict's test. Benedict's test in the sense it is same like Fehling solution. No difference. Only thing what in the sense instead of sodium potassium tartrate we have to take citrate we have to take. Citrate ions we have to take. Instead of sodium potassium tartrate what we have to take means citrate ions we have to take. Okay. So Benedict's test means instead of sodium potassium tartrate what we have to take citrate ion we have to take. Remaining things same. Alkaline OH minus, copper sulfate solution aqueous, everything same. Reaction also same like Fehling solution. So even in Benedict solution also cupric is converting into cuprous. So cuprous oxide red precipitate we are getting. Okay, sir. So for Benedict solution how the test is there, that we got an idea. So Benedict's test also giving the answer for carbonyl, that means aldehyde but not for ketone. Okay, sir. Now we'll go for a next reaction. Next reaction will take, what is a reaction in the sense Bayer Williger oxidation. Bayer Williger oxidation. Bayer Williger oxidation. This will take Bayer Williger oxidation. What is the reaction? We'll see. We will take carbonyl compound. We are taking carbonyl compound. Then we will take peracid. Peracid we have taken. So what we are getting in the sense we are getting ester. We are getting ester. Like this we are getting. This ketone, we are taking ketone. That means between this CO group and this R group, what is introduced in the sense oxygen is introduced. So what is the mechanism involved in this one? That we will see. Now we are taking the carbonyl compound. We are taking the carbonyl compound. Okay. Now H plus is coming for attack. From acid, H plus is coming for attack. This oxygen is attacking this H plus. Therefore, what we are getting in the sense RCO. Here one lone pair will be there. Here like this we will get. Okay. So H plus is attacking the oxygen. This H plus is attacking this oxygen. Then we will take a per acid. We will take per acid. For example, pH CO3 CO3H. pH CO3H. Per acid will take. How per acid is attacking this one? That point we'll see. How per acid is attacking this. So in the per acid is attacking this one. In the per acid, this oxygen is attacking this carbon. This pi bond is migrating like this. Therefore, we are getting RCOH. Here R, here OH, OCOPH. Here what is there means positive charge is there. Okay. So we are getting like this. We are getting like this. Next, what happens means H plus will be removed. H plus will be removed. Where and all positive charge is there, there and all we have to remove H plus. Okay. Where and all positive charge is there, there and all we have to remove H plus. Okay. Here we will remove H plus because oxygen is having positive charge. Therefore, we will get RCR. Here OH. Here two lone pairs will give. Here O, here O, CO, pH. Like this will give. Okay, H plus is removed. Okay, what is the next step? We'll see. Next step, what happens means this bond is migrating here. That bond has migrated. Okay, when that bond is migrating, this R is migrating to this place. Then this bond is migrating like this. Okay, so how the migration takes place? You see here. How the migration is taking place. This OH bond, this bond is migrating here. This R group is migrating to this oxygen. This bond is migrating. Therefore, that PHCOO minus leaves. PHCOO minus leaving. So what we are getting in the sense, and H plus also leaving. H plus also leaving. So what we are getting in the sense ROCOR. Okay, we are getting ester. We got ester. Okay, like this we got. Now it is a mechanism. Now we will see the reactant and we will see the product. Here RCOR is the reactant, product is ROCOR. That means between this R and CO, O is introduced. Between this R and CO, O is included. O is introduced. Okay, between this R and CO, we have introduced O. So we got what in the sense, we got ester, we got it. Okay, so we got ester. Sorry. What is how the reaction takes place means first H plus is attacking. Here H plus is leaving. Okay, H plus is leaving. Here peracid is coming. Peracid is coming. In this peracid, what is leaving in the sense PHCOO minus is leaving. PHCOO minus is leaving. One H plus also leaving. So this oxygen alone is introduced here. Okay. So first one H plus adding. Here one H plus is removing. This H plus is removing here. This PHCOO minus is removing. This oxygen alone is adding. Okay. Oxygen alone is adding. Sir, here this here migration takes place. Here migration takes place. What is migrating here? Both are R group. Therefore, we have made one R group to migrate. Sir, what about migration tendency? How the migration tendency will be there? If in this R and this R, if it is different, how the migration tendency will be there, that we have to see. No, sir. How the migration tendency will be there, that point we have to see, sir. So now we will go for a migration tendency we will take. Now we will discuss about migration tendency. For this case, we will take like this. We will take a that we will take like this. Okay. Now we will consider that one is aryl group, one R we will consider as aryl group, another R we will consider as hydrogen. Like this we will consider how the migration tendency will be there, that we will see. So one R group we are replacing by aryl group, sir. One R group we are replacing by aryl group. Another R group we will replace by hydrogen. Okay, another R group we will replace by hydrogen, which is having higher migration tendency, that we will see. Which will migrate. This phenyl ring will migrate or hydrogen will migrate, that we have to see, sir. If phenyl ring is migrating, how the transition state will be there, that we will see. If phenyl ring is migrating, how the transition state will be there, that point we will see. Okay, sir. Now this phenyl ring is migrating. If phenyl ring is migrating, how the transition state will be there, that point we have to see. Okay. Now here pi bond is there, no? This pi bond is attacking this. So pi bond is making partial bond here, partial bond here. Okay. Like this attack will be there, partial bond shifting this side, partial bond shifting this side. If hydrogen is migrating, how the transition state will be there, that we will see. Here hydrogen we will write. Here partial bond breaking, partial bond forming, partial bond transferring, like this. Okay. So here which is having higher stability, in the sense this is having higher stability, therefore we can say aryl has higher tendency to migrate than H than alkyl. Okay, we can say like this. Aryl migration tendency is more when compared to hydrogen. Hydrogen migration tendency is more when compared to alkyl. Okay, so like this we are saying, sir. Now we will say in the aryl different groups are there, means how the migration tendency will be there, that we will see. One we will take para-toluene. One we are taking para-toluene, we will take para-toluene, that we will take para-toluene, in the sense here CH3 will be there. Para-toluene. This CH3 is electron donating group, therefore this CH3, if you take CH3 here, so what will happen, we'll see. What is happening here, that means this bond is coming here, this bond is coming here, this bond easily migrating to this place, isn't it? So para-toluene means like this. Phenyl, in the sense supporting group is not there, so that para-toluene and phenyl, which is having higher migration tendency, that you think it. Okay, sir. Now we will take a para-anisile. Para-anisile we will take para-anisile, para-toluene, para-toluene, para-toluene. Then we will take phenyl, then we will take chlorophenyl, para-chlorophenyl, 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 para-nitrophenyl, 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 like this is there. Sir, how the migration tendency will be there, we'll see. This lone pair comes here, this lone pair comes, this bond pair comes here, this bond pair comes to this place. Here sigma bond is coming, pi bond is coming, pi bond is coming, like this. Here nothing. Okay. Here what happens means it shows minus I effect. Therefore, this tendency will be less. This shows minus R effect. Therefore, like this going in the sense coming to this place tendency will be less. Therefore, here plus R, it is plus R, it is hyperconjugation. It is plus R group, easily donating electron cloud, so having more migration tendency. Hyperconjugation, so more migration tendency than this. It is minus A effect, therefore phenyl is having more tendency. Here NO2 group shows minus R effect, therefore here more tendency. Like this migration order will be there like this. Aryl group means. So alkyl group means how the migration order will be there. Alkyl group means how the migration order will be there, that we will see. Alkyl group means how the migration order will be there, that we will see. Now we will take a tertiary alkyl will take tertiary alkyl, secondary alkyl will take then primary alkyl will take primary alkyl, then we will take methyl, okay, then we are taking methyl. How the migration tendency will be there means it is this bond has to break and it has to be formed with the oxygen, isn't it? So how it is there means like this is there, okay, like this is there. Now with this bond has to break, okay, so this bond has to break, then here partial bond like this should form, while CH3 is showing plus I effect. Because of plus I effect, this bond breaking is easy, formation will be easy. Therefore, tertiary shows more migration tendency than secondary shows more than primary shows more than methyl. Like this migration tendency will be there. Okay, so we got how the migration tendency is there, we got. Now we will say the product, we will say. Okay, so now the reactant is this one, PHCOMe, it is a reactant. Now where oxygen will come, okay, which group is migrating, between that and CO only oxygen will be introduced. Okay, you see that here this group is migrating means this R is making bond with O. This R is making bond with O. This COH becomes carbonyl compound. This COH becomes C double bond O. This COH becomes C double bond O. This R is migrating means it is making bond with O. Okay. Therefore, now we can say this compound given. First, we have to see which is having higher migration tendency. Aryl is having higher migration tendency. Then, which is having higher migration tendency? Between that and CO, you have to introduce oxygen in Baeyer-Williger oxidation. Therefore, between pH and CO, introduce oxygen. It is a product. Okay, sir. Now we will take a reactant is a MECO, CME3. It is a reactant. Now, where we have to introduce oxygen means which is having higher migration tendency, we have to first find it. Which is having higher migration tendency? Tertiary alkyl. Tertiary alkyl is having higher migration tendency. Therefore, between that and carbonyl compound, carbonyl group, we have to introduce oxygen. Okay. So between tertiary alkyl and CO group, we have to introduce oxygen. Okay. Sir, that is the product. Next, we will see. Next, we will take MECOMe like this given. Now, Baeyer-Williger oxidation. Where to introduce oxygen? Where to introduce oxygen in the sense which is the migrating group, that we have to see. Which is the migrating group means not Me, not methyl group. MECO is the migrating group. Why MECO is the migrating group? Because first step is what? H plus attack. H plus will attack any one of the oxygen. H plus will attack any one of the oxygen. Okay, this is the first step. What is the second step? Second step is the per acid oxygen is attacking. Per acid oxygen is attacking. Okay, this oxygen will attack this carbon only, no? Isn't it? Then which will migrate? Now either MECO has to migrate or methyl should migrate, isn't it? So one is MECO, another one is Me. These two, in these two, anyone should migrate. Correct? Sir, which will migrate easily? That we have to see. Which will migrate easily? MECO or ME? That point we have to see. Sir, we will write another step. Next step we will write. So MECO, here COH, here Me, here OH, OCOPH. We have written like this. From this H plus we can remove. Here positive charge will be there, therefore H plus we will remove. Okay. So we will remove H plus. Now we have to see the migration. Migration we have to see. Now what will happen? This bond will migrate. Sorry. Now which group will migrate? We have to see. Suppose this group is migrating, we will take. It is migrating, then it is migrating. Okay. Which is having higher tendency to migrate. Either MECO or this methyl. This methyl also can migrate, no. So methyl will migrate or MECO migrate in the sense MECO will migrate because of pi bond. Because of pi bond, MECO has higher migration tendency than Me. Therefore, where O will be introduced in the sense it at this place O will be introduced. Therefore, the product is this one. This is the product. This is the product we can say. Okay, sir. Now we will see next reaction. We'll see. Now we have given aldehyde. Now Baeyer-Villiger oxidation means where O will be introduced, which is having higher migration tendency. We have to find it. H is having higher migration tendency than R. Therefore, between H and carbonyl group, oxygen will be introduced. Between H and carbonyl group, oxygen will be introduced. We are saying okay. Next compound given ArCOH. ArCOH. Here it is aryl and H, which is having higher migration tendency means AR. So between AR and CO, oxygen will be introduced. Between AR and CO, oxygen will be introduced. We are saying okay. Next given is PHCOET. PHCOET. Okay, which is having higher migration tendency. In this case, pH is having higher migration tendency. Therefore, between pH and CO, oxygen will be introduced. Between pH and CO, oxygen will be introduced. We are saying between pH and CO, oxygen will be introduced. Okay. Next, we will take a pH CH2, pH CH2, COMe. This will take where oxygen will be introduced. We will see which is having higher migration tendency. We will see. This is having higher migration tendency than this. Okay. Why this is having higher migration tendency? That we will see. Okay. So now we will take here phenyl ring. It is CH2. It is CH2. This is this CO will take it as COH. Will make that peracid is bonded. Peracid is bonded. Therefore, we will take like this. Peracid is bonded. So we will write like this. Okay. Now we will see the migration, which is having higher migration tendency, that we will see. Okay. Now like this is that which is having now which bond how the migration of bond will be there. This bond is migrating. If this group is migrating to this place, then this bond is migrating. Another possibility, this method. Now this group is migrating in the sense this carbon is getting electron deficiency, that is aided by this phenyl ring. Phenyl ring will support. For methyl, no support. Okay. Therefore, it is having higher migration tendency. Okay. This is having higher migration tendency. Therefore, O will be introduced at this place. Therefore, pH CH2, O will be introduced here. So we can write like this. Okay. So next one we will take. Next one. Me2CH, that is isopropyl COET, like this will take. Here where O will be introduced, that we will see. Here which is having higher migration tendency means isopropyl is having higher migration tendency. So between isopropyl and CO, oxygen will be introduced. Between isopropyl and CO, oxygen will be introduced, we are saying. Okay. Sorry. Next reaction will take. Now we will take like this. Cyclopentanone. We are taking cyclopentanone. how the reaction will be there. We will see the mechanism for this. Okay, so cyclopentanone first OH will, this is becoming what we'll see, oxygen here positive charge, here CH2 CH2, like this I have written. First step H plus attack, then peracid attack. Okay, peracid attack we will see, then we will take a peracid attack. Peracid is attacked. Okay, so we got like this. Seriya? Now we have to see the migration. Now we have to see the migration. We have to see. So how it is migrated, we'll see. This bond is coming here. This bond is shifting here. It is attacking here. It is shifting. Okay. So therefore, what happens? You see what membered ring we will see. Number 1, number 2, number 3, number 4, number 5. Here one bond. 6 bonds. So 6 bonds compound is obtained. Okay, 6 membered ring. This is carbonyl group. This is carbonyl group. That carbonyl group will give. This is C double bond O. That C double bond O. This C double bond O carbon is having this oxygen. Carbon is having this oxygen. This CH2 carbon is making bond with this oxygen. Okay, CH2 carbon is making bond with this oxygen. Therefore, a 5-membered ring is becoming 6-membered ring. Okay, that means where oxygen is introduced in the sense between this carbonyl group and this CH2 oxygen is introduced. Here this is the carbonyl group. This side CH2 is there, this side also CH2 is there. This is carbonyl group, left side CH2 is there, right side also CH2 is there. So equivalent position. So any one side you take. Okay, any one side you are taking. So next we will take this cyclohexanone will take. Now Baeyer-Villiger oxidation means make it oxygen introduce and make 7-membered ring. That's all. Make 7-membered ring. Okay. Next we will take, it is phenyl ring. Here we will take a diketone. We will take diketone. We have taken. Now we will introduce oxygen. Where we have to introduce oxygen? It is same like what in the sense previous case. Like this we have discussed already. Therefore, between 2 ketone you introduce oxygen. Between 2 ketone you introduce oxygen. Okay. So between 2 ketone we are introducing oxygen. So CO, here O, here CO. Now it is this 6-membered ring will become 7-membered ring. 1, 2, 3, 4. 4 bonds over, remaining 3 bonds. Remaining 3 bonds. 7-membered ring. Like this we have to give. Okay. So next we will see reduction of carbonyl compounds. We will see reduction of carbonyl compounds. Now I will take a CH3, CH double bond, CH, CHO. Okay, it is unsaturated carbonyl compound. Unsaturated carbonyl compound. To this, what is the reducing agent I am giving means nickel hydrogen. Nickel is the catalyst, hydrogen gas. What is happening means a double bond is converting into single bond. Double bond is converting into single bond. Then CHO, the CHO aldehyde is converting into primary alcohol. Aldehyde is converting into primary alcohol. CC double bond is converting into CC single bond. Here what is a catalyst means nickel hydrogen. Catalyst is nickel metal and hydrogen gas. Okay. Then we will take a reducing agent. What in the sense lithium aluminum hydride. Lithium aluminum hydride reducing agent will take. Here what is happening? What is the product is obtained in the sense CC double bond is not affected. Aldehyde is converted into CH2OH. Aldehyde is converted into primary alcohol. Aldehyde is converted into primary alcohol. So lithium aluminum hydride is not affecting CC double bond. Lithium aluminum hydride is not affecting CC double bond. Sorry. Now we will take another reactant. Here phenyl ring. Then CH double bond CH CHO. Now we will add the what is the catalyst. We will take catalytic hydrogenation. Will take catalyst is nickel and hydrogen. So what is happening here? We'll see this phenyl ring contains pi bond. Pi bond will not go reduction under normal condition. Under drastic condition only it will undergo reduction. So phenyl ring 5 bonds we have not affected. This CH double bond CH is converting into single bond. Then CHO, this aldehyde is converting into CH2OH. Aldehyde is converting into CH2OH. Aldehyde CHO is converting into CH2OH, we said. Then here we will add lithium aluminum hydride. Lithium aluminum hydride reducing agent we will add. This phenyl ring, 5 bonds are not affected. Phenyl rings contains 5 bond that is not affected. This CH double bond CH, this double bond is converted into single bond. The CH double bond CH is converted into single bond, but here no. Therefore, it is alpha beta unsaturated. It is also alpha beta unsaturated, but at beta position phenyl ring is there. When beta position is having phenyl ring, then CC double bond is undergoing reduction in the presence of lithium aluminum hydride. So lithium aluminum hydride reduces CC double bond if beta position is containing phenyl ring. Then we will write this CHO will write it as CH2OH. The CHO group we will write it as CH2OH, we will write it. Okay. So this compound we are getting. Then this is taken for sodium borohydride. Sodium borohydride is a reducing agent. Sodium borohydride is a reducing agent. Here what happens we will see. This phenyl ring will write as it is. This phenyl ring will write as it is. CC double bond will write as it is. CC double bond will write as it is. The CHO will convert into CH2OH. The CHO will convert into CH2OH. Okay, the CHO is converting into CH2OH. CC double bond is not affecting. Here sodium borohydride is a reducing agent. Sodium borohydride is a reducing agent. CC double bond is not affected, but lithium aluminum hydride is reducing CC double bond. Sodium borohydride is not reducing CC double bond. Okay, sodium borohydride is not reducing CC double bond. Lithium aluminum hydride is reducing CC double bond. Okay, sir. So like this reduction is possible. So we have to remember these things. We have to remember. Okay. Next reaction we'll see. We'll take a reducing agent is what means lithium tri-tertiary butoxy, aluminum hydride in THF solvent will take. Okay, THF solvent will take. It in this reducing agent, what happens means aldehyde is converting into primary alcohol. Aldehyde is converting into primary alcohol. Then ketone is converting into secondary alcohol. Ketone is converting into secondary alcohol. This ketone, CO group is ketone. C double bond O is ketone. Ketone is converting into secondary alcohol. Aldehyde is CHO. Aldehyde is converting into primary alcohol. Ketone, CO is converting into what in the sense secondary alcohol we can say. Ketone is converting into secondary alcohol with this reducing agent. Next we will go for a Mervin-Pondroff-Verley reduction. Next reduction is what means Mervin-Pondroff-Verley reduction. Verley reduction that we will see. MPV reduction. MPV reduction will take. Here what is the catalyst in the sense aluminum isopropoxide. Aluminum isopropoxide is the catalyst. Aluminum isopropoxide. It is isopropoxide. Aluminum isopropoxide we have take. Isopropoxide in the sense like this, it is called isopropoxide. How many we have taken in the sense 3 we have to take. So isopropoxide 3 times we have given. Aluminum isopropoxide we have given. It is a catalyst here. It is a catalyst. What is the solvent in the sense isopropyl alcohol is the solvent. Isopropyl alcohol is the solvent here. This will do what in the sense carbonyl compound will convert into alcohol. Carbonyl compound will convert into alcohol. Carbonyl compound is converting into alcohol. CC double bond is not affected. Then CC triple bond also not affected. CC double bond is not affected. CC triple bond also not affected. Carbonyl compound is converting into alcohol. Carbonyl group C double bond O. Carbonyl group C double bond O is undergoing reduction to give CHOH. Carbonyl group C double bond O is converting in is undergoing reduction to give CHOH, like this we can say. Okay, carbonyl group undergoing reduction and giving CHOH, like this we can say. So it is called a MPV reduction, we can say. In this MPV reduction,